Let's talk about the solution to R3. R3 gives us a graph of f, which consists of line segments. So again, we might be thinking about pulling out some geometry formulas here. So they give us a graph of f, but they're not going to ask us much about f. They're going to ask us mostly about a function g. Whoops. And g is the area function of f, starting at 0 and going to x. So right away, I know the fundamental theorem of calculus, so I know that the derivative of g, the derivative of this area function is, yes, f of x. G prime is the derivative of that, which is f of x. The derivative of an area function is that integrand with that variable plugged in times the derivative of that variable. It's written right here. That's the fundamental theorem of calculus, one of them. I call it the first one. Okay, so what I have my students do, make sure if this is the situation you're in and this situation gets repeated, this kind of a question exactly like this has been on the exam countless times. Relabel the graph of f as, yep, this is also equal to the graph of g prime. So you know for the rest of this question, you're looking at the graph of f, yes, but you're also looking at the graph of the derivative of g. That's useful information. All right, part A, find g of 4, g prime of 4, and g double prime of 4. Great questions. G of 4, we're going to have to do an integral because g is defined to be this area. So g of 4 is the integral from 0 to 4 of that function. So from 0 to 4, I have to find the areas of these two regions. The area of this one is negative, and the area of this one is positive. So that's the area of a triangle. That's the area of a trapezoid. I did not show my work on that one on here, but those area formulas aren't too bad. G prime of 4. This is where having some advanced thinking about what this all means really pays off. What's G prime of 4? Well, this is the graph of G prime, so G prime of 4 is 0. What about G double prime of 4? How do I find G double prime? Well, G double prime is the derivative of G prime. And since I have the graph of G prime sitting here, how can I find the derivative of this at some point? Well, to get the derivative off of a graph, you need to find the slope. So G double prime of 4 is the slope of the graph of G prime, which is the same as the graph of f at 4. There's our work. Part B. Does G have a relative minimum, a relative maximum, or neither at x equal 1? So we need to look at x equal 1. This should be a pretty easy question as soon as you realize that what you're looking at is the graph of G prime. This is the graph of G prime. What can you describe? What would you say that G prime is doing as I pass across x equal 1? Well, it's pretty clear that G prime is going from negative to positive. What kind of a graph do I have whose derivative is going from negative to positive? Well, that graph must have a minimum. See this derivative? That slope is negative, that slope is positive. The derivative of this changed from negative to positive, just like that situation. If I were looking at the graph of the derivative, this would be the graph of G, and it's got a minimum. All right, that wasn't too bad. Now it gets a little bit crazy. Part C, suppose that f is defined for all real numbers and periodic with a length of 5. What does that mean? That means this part of the graph along that x from 0 to 5, this structure right here, I'm not going to draw it, repeats over and over and over again. That's what it means to be periodic with a length of 5. to show you that where it starts, they claim that this is 2 periods, so I can see that. Here's 1 period, and there's the other one. Okay, given that g of 5 is 2, find g of 10. How do I find, let's see, g of 5 is 2. What would that mean? G of 5, well, it's not on this graph. It's not negative 2 because this isn't the graph of g. This is the graph of g prime. What's the meaning of g? How's it defined? Well, g of 5 would be the area under this graph from 0 to 5. G of 5 is this area taken as negative, that area, and this area of that triangle, which doesn't look much like a triangle, taken as negative. So if I could find these 3 areas, keep that positive, that negative, and subtract, and add them all up, I guess, I would get the area from 0 to 5. That would be g of 5. Well, I don't have to find the area because they told me that that was 2. How do I find g of 10? Well, g of 10 is just an accumulated area of 2 plus another accumulated area of 2. This graph keeps going, remember, it's periodic, so there's another, boy, I did that terribly, but there's another one of these whole things on the other side of here that they didn't draw. So they both have the same areas. One's got an area of 2, the other one's got an area of 2, g of 10 is 4. Write an equation for the line tangent to the graph. There's 2 parts to part C here. Write an equation for the line tangent to the graph of g, holy cow, at x equal 108. How are we going to go all the way out to 108? Well, remember, it's periodic with a period length of 5. So what I want you to do is imagine this period that's way over there. Now, I didn't draw it really all that well, but this is in fact 21 periods away from the first one because I'm going from 105 to 110. So I've got 21 periods up to here, and then here's another one starting at 0. What do we want? We want, well, let's go back to this for a second. What do we need to write an equation? We need a point and a slope. So I need g of x, or I need g of 108 for the point, and I need g prime of 108 for the slope. Don't forget, what's this the graph of? This is the graph of g prime. So returning to this, I want g prime of 108. Well, I can read that right off the graph. G prime of 108 is just simply 2. Now, what about g of 108? What about all of the area up to there from 0? That's what I have to find. Well, don't forget, each one of these periods, I guess you could call it, has an area of 2. There are 21 such periods right to here, so that's an area of 42. And then this area, which you have to find with some geometry formulas, turns out to have an area of 2. It's pretty easy. My drawing's not very good, but this area and that area combine to equal 0, and then all you have is this area right there. So g of 108 is all of this area, and it is equal to 44. Now I have a point and a slope. Here is the slope. Remember, we read that off the graph. And there's the y-coordinate of the point. There's the x-coordinate of the point. Point-slope form. Okay. That's R3. Let's see. Certainly fundamental theorem question. I think you're going to want to expect to see something like that. If you do find yourself in that situation, that's a great label to make because it makes the rest of this problem quite a bit clearer to understand. So, thanks for listening. See you later.